Okay, permutations is an arrangement of items in a particular order. So today we're focusing on number of possible outcomes. Okay, how can we find out how many possible outcomes there are? Which is important to probability because the probability is the number of outcomes over the number of favorable outcomes. Let's reverse that. The number of favorable outcomes over the number of possible outcomes. Okay, so if you don't know how many outcomes there could possibly be, then you can't find the probability. So we're going to use permutations and combinations today to find out the number of possible outcomes. So permutations is an arrangement of items in a particular order. You can often find the number of permutations of some sets of items by using the multiplication counting principle. So let's do this for the first one just by kind of trying to figure out how many permutations are there in the numbers 3, 2, and 1. So in other words, how many different ways can I arrange the numbers 3, 2, and 1? So the first way is 3, 2, 1. Then I could do 3, 1, 2. Then I could do 1, 2, 3. And then 1, 3, 2. Then 2, 3, 1. Then 2, 1, 3. Is there any other order that I missed? So how many different ways can I do that? 6. Okay. Now that wasn't too bad considering I only had 3 numbers. But what if I had a lot more, like 4 or 5 or 6 or 7? Okay, would I want to be arranging them in various orders forever? So the multiplication counting principle is that I can just take these. The very first time I'm choosing a number, how many numbers am I choosing from the very first time? Is 3. Now after I've picked 1, how many are left? 2, so I'm choosing from 2. So the next time I pick, I'm going to pick from 2. Now I've chosen 2, how many are left? 1, so the last time I only have an option of 1. So I can just multiply them all together, 3 times 2 times 1, and that'll get me the number of possible ways I can arrange them. Any questions over that? Okay. We have a button for that on our calculator. It's a factorial, okay? N factorial is the exclamation point. And 6 factorial, or 6 exclamation point, means 6 times 5 times 4 times 3 times 2 times 1. Okay? So we're all going to look on our calculator. We're going to look for this button or this button. Or you might have this button. You're going to start by entering the number 6. Then you're going to look for that button. So everybody look for that button. If you have this probability button, then you're going to hit that probability button and you'll see the exclamation point and you're just going to arrow over until you get to it. So once we enter that into our calculator, class, what do we get? 720. Okay, and that's the number that I can arrange those 6 numbers in. So, or arrange 6 things. I can arrange them in 720 different ways. Okay? Did you want to write out 720 different ways to arrange that? No. So that's why we have a wonderful button for it. Thank you, people who can program our calculators. Okay? So now we want to arrange how many ways can we schedule 10 dogs to be groomed. So again, that's just 10 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. Wow. Lauren, what did you get? 3,628,800. Everyone able to get that number? Okay. answer. I can arrange 10 things in 3,628,800 different ways. Lots of fun. Now, factors are if I'm arranging all of my items. Okay? Permutation is when I want to choose from those 10 items. So say I only want to choose 3 of those items in that last one. Okay? So we would use a permutation for that. A number of permutations of n items of a set of arrangements are items at a time is p or npr. Okay? And how we would do that, our formula for permutation of a certain number of numbers is n factorial divided by n minus r factorial. Any questions over that? Okay? You also have a button on your calculator that looks like this. Okay. If you have, it's probably in the probability, oopsie, PRB. My little tiny ones do not have it. Okay, so the ones you borrowed from me, you're going to have to plug in this. Your phones do not. I just looked at his phone and it did not. Okay? And I'll show you how to enter them on both of them. This is why scientific calculators are kind of important, you guys. Okay, and so what this means is I'm going to take 10 items and I want to choose 4 of them. For permutation, order matters. So let's talk about some things that I choose where the order would matter. Okay. If I chose from people to be first, second, or third place, okay, would it matter to me if I was first, second, or third? Yes, it matters to me because I want to be first. Okay? So that would be a permutation. Okay, what if I was doing a raffle? Okay, and the first thing I pulled, you won a car. And the second time I pulled, you won a toaster. And then the third time I pulled, you won $5. Okay, would I care? Yes, I would. What if I entered a raffle and I drew 3 names and everybody, all 3 of them won $100? Would it matter what order you got called in? Very good. So for permutation, it's when we care about the order in which we're picked. Okay? If it doesn't matter, like I'm not going to win something different, we're all going to win the same thing, then that would not be a permutation. That order doesn't matter. I don't care if I get chosen first or third. I get the $100 kind of thing. But for permutations, we will use where order matters. Okay? It's for where order matters. Okay, so let me show you what this means. What this is 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Everyone's writing this down. Then it's divided by 10 minus 4 factorial. Class, what's 10 minus 4? What is it, class? Okay, oh, thank you. So then that's 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. What's nice about this is I know what 6 divided by 6 is, and 5 divided by 5 is, and 4, and 3, and 2, and 1. So basically, these will all reduce to 1. So what I really just need to multiply is 10 times 9 times 8 times 7. Everyone does that? And I should get 5,040. Any questions over that? Now, if you have this button on your calculator, we're going to show you how to do that. You're going to hit the number 10. You're going to find that button on your calculator. And then hit 4. If you have one of my little calculators, you're going to hit this. Do 10 factorial. Everyone's doing this, so we get to learn how to do this. 10 factorial. Then divided by 6 factorial. Then hit equals. Okay? Is anyone not able to get that 5,040 using your NPR button or the factorial button? If you can't get that, then please ask. I will show you how to do it. We're all good? Okay, good. Okay, in your homework, this is what I'd like you to do. Okay. So 15, choose 6. So I'm going to choose 6 people out of the 15 people that are there, or 6 items out of the 15 items that are there. Okay. You're going to write the formula of 15 factorial divided by 15 minus 6 factorial, which gives me 15 factorial divided by 9 factorial. Okay. Now you can use your calculator, however you know how to do it, to get your answer. Okay, that's 3,603,600. Do we agree, class? Yes, okay. If you did not get that, then you need to try it again or ask. Okay, so now there's the word problems. 7 yachts enter a race. We have first, second, and third places will be given to the 3 fastest yachts. How many arrangements of first, second, and third places are possible with 7 yachts? Okay, anyone have an idea as to how I could write that? Yeah? Okay, but it's not just, because I'm not going to choose all 7. That's if I was going to choose all 7 of them. How many am I choosing? 3, because I have first, second, and third. So I need to do the permutation and choose 3. So again, in your homework, you're going to do 7 factorial divided by 7 minus 3 factorial, which gives me 7 factorial divided by 4 factorial. Okay, then what did you get? 840? I think 210. Do 7 factorial? Divided by 4 factorial, and then hit equals. Okay, give me a second. Next one. Now we're just going to add these 2 permutations. So again, rewrite it as 10 factorial divided by 10 minus 3 factorial, which is 7 factorial, plus my 8 factorial divided by 8 minus 2 factorial, which is 6 factorial. 8 minus 2 is 6. 10 minus 3 is 7. Okay, Rachel, what did you get for the first one? Okay, sorry. Yeah? 7 what? 20? Michael, what did you get for the second one? Did you get this? Did you plug this in? Where is it? $56. Okay, we then add them and get 776. Any questions over that? Okay. Now I learn combinations. And combinations is slightly different. Okay, with combinations, order doesn't matter. Okay, I don't care which order I get picked in, we all win the same prize. So it's like when I raffle on the day of our test and I raffle off 5%, you don't care if you got picked first or third or second, you all get 5% on the test. Okay? So the formula is very similar to permutations. Notice it's n factorial divided by n minus r factorial. This is the thing that changes. You have that extra r factorial on the bottom. Okay? So that's the difference between the two. So this is 8 factorial divided by, there's a typo here, so everyone change it. This should not be 8. That doesn't make sense because then that would just cancel everything out. This should be a 2 factorial. 2 factorial. So everyone change it for me. Kind of very important. So that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by the 2 factorial is just 2 times 1. Then the 8 minus 2 factorial, very good. 8 minus 2 is 6. So we do 6 times 5 times 4 times 3 times 2 times 1. Now it's nice again because I can divide these all and it all cancel out. Then I can also reduce this. 2 can go into 8 4 times. And then just multiply 4 times 7 and get 28. Okay. So now let's try the calculator and see if we match our answer. Okay, so again, you're going to look for the NCR button. Okay, and 8, then the NCR button, and then choose 2, and you should get 28. If you have my little calculator, you're going to do 8 factorial divided by 2 factorial divided by 6 factorial, and hit equals. And you too should get 28. So everybody try that. Make sure they can get 28 on the calculators. So again, in your homework, I want you to write it like this. 8 factorial divided by 3 factorial times 8 minus 3 factorial. That gives me 8 factorial divided by 3 factorial times 5 factorial. Plug into your calculator for me. Jay, what did you get? Still doing it? Lindsay, what did you get? Okay, so we did something wrong there. Yeah? 56.
And then that button, NCR, yeah, okay, and then 5, and then
792. Make sense?
Yeah.
Okay. And then you'll do the same thing with this one.
Okay.
I'll be right there. you're just going to divide the two. Oh, it's turning on now? Awesome. Thank you. Boo. No. Okay, so again, class, just to review what we just did, that I did not record for those of us who are watching the video. This is 12 factorial divided by 5 factorial times 12 minus 5 factorial. We're using this formula right here. So when I simplify it, I get 12 factorial divided by 5 factorial times 7 factorial. If I have this button, then I can just use this button and get 792 for the top. Okay? If I don't, then I need to do this work. If I just have a factorial button on my calculator, I have to use this. Okay? So all of you using phones, this is what you're going to have to do. Okay? 6 factorial then for the bottom. We're going to do this bottom one, which is 6 factorial divided by 2 factorial times 6 minus 2 factorial. Again, I'm using this formula. That simplifies to 6 factorial divided by 2 factorial times 4 factorial. Okay? Or if I have my 6 choose 2, I can use that button on my calculator and I should just get 15. Yes?
So if you didn't have the button, it would really be like 6 factorial divided by 8 factorial?
No. Mm-mm. Divided by 2 factorial divided by 4 factorial.
Oh, so you divide it first by 2 and divide it again.
4 factorial, yes. Any other questions over that? Okay. Then you divide the scenarios and you get 52.8. Okay. Let's move on to our word problem. Manuel owns 8 baseball hats and 10 sweatshirts. Okay, he's packing for a trip and wants to bring 3 hats and 4 sweatshirts. How many ways can he choose what to pack? So there's 2 different things occurring here. I'm choosing hats and then I'm choosing sweatshirts. Okay, so let's start with our hats. Okay, how many different hats am I choosing? There's 8 hats, and how many am I choosing? 3. So that's 8, choose 3. Okay. Then we also want to deal with our sweatshirts. How many sweatshirts are there? And how many am I choosing? 4. Now I'm choosing combinations because it doesn't matter which order in which I pick my sweatshirts or my hats. If I pick one hat first, does it matter? No. He doesn't win something special. He still goes in my backpack. Okay? Now, since I want them both to occur at the same time, I need to multiply those 2 things together. So again, if I have this button, I can just enter it as it's written. If I don't have this button, I just have factorials, I need to do 8 factorial divided by 3 factorial, and then subtract 8 minus 3, and get 5 factorial. I know, it's letting me thinking about it. Then I'm going to do 10 factorial. Let me answer that one. Divided by 4 factorial, and then 10 minus 4, which is 6 factorial. Very good. Lindsay, did you get the first one? 8, choose 3. 56. Class 3 agree. Oh, good. Reagan, what did you get for the second one? 210. Do we agree, class? Okay, we multiply the 2 together, and we should get 11,760. Any questions over that? So whenever we want 2 events to occur at the same time, you multiply them. So I want to pack hats and sweatshirts, so I have to multiply them. Any questions over that? Okay. Okay, now I want to find the probability. We've been dealing with how many possible outcomes there are. Now we want to add in our probability of that. And remember, Probability is the ratio between favorable outcomes versus possible outcomes. Favorable outcomes are the outcomes that I want to happen. So 10 candidates are running for 3 seats in the student government. Tom, Anna, and Julio are 3 of the candidates. What is the probability that all 3 of them will win or be chosen? Okay? So we first want to deal with permutations versus combinations. Perm versus com. Okay. Is this permutations or combinations? Does it matter which order I get picked in? Doesn't matter, I get to be on student council. Okay, it doesn't talk about being president, vice president, or secretary. It just means I get to be on student council, and that's all they're talking about. Now, if they changed it to president, vice president, and secretary, then order would matter because I'd care which one I got, right? Okay, but this is just being on student council. So this would be a combination because it doesn't matter who gets chosen first, second, or third. How many people are running for these offices? 10 people are running. I'm going to choose 3. So everyone find that value. However you need to do it using your calculator. Okay, Connor, what'd you get? 120. Class, do we agree? Yes, we do. Now that's the number of possible outcomes, okay? I want my favorable ones. So 120 is on the bottom. How many favorable outcomes where all 3 of them get picked is there? If all 3 of them are going to get picked, how many ways can I do that? Since order doesn't matter, 1. Since order doesn't matter, 1. There's only one way that all 3 of them will get picked. Okay, there's ways where 1 of them will get picked or 2 of them might get picked. Okay, but there's only one chance that all 3 of them are going to get picked because the order doesn't matter. Any questions over that? So then we would plug that into our calculators and get an about, I think it's 0.008. Okay, 33. I would move my decimal over twice. So the percentage is 0.8%. So it's less than 1% chance. Okay? So it's a very small percentage. Does that make sense? We're all good? Okay.